Here, now you have audio. Yes, yes, yes. I was just switching over from one to the other. And let's now get rid of this one. So we are going to switch this one off. Okay. So now we are off of here. Is that right? Is that what I want? So this one's off. We are all moving to the YouTube. Okay. We're all moving to the YouTube. Let me go back to there. We're here. This one is moving. Okay. Right. Oh, now I can even hear the echo is because there are some people here who are playing this. But what I'm about to do is I'm actually going to mute my Zoom as well. So I will not be able to hear you guys. There we go. And we're going to do the entire thing over onto the YouTube Live instead. So I'm just going to wave to test the latency. That's what we have. And welcome back. So here we go. Yes, the echo is coming from the Zoom audio that's playing out, and in fact, I'm going to make the Zoom audio quiet. There's no point being on Zoom anymore, actually. Everything now is being run on the YouTube Live instead. Here we go. Switch to this. And this. Excellent. Okay, well, welcome everybody, and thank you very much for coming in and for watching us solve the first problem. In fact, the problem that we were just solving was a problem called an inequality. The inequality says that, unfortunately, there's a limit on how many people can be in a Zoom. And because we had so many people who wanted to come and join this, which we're very happy about, we have now moved over to a platform which can handle many. And in fact, I think this also solves another problem, which is that people had commented that on the Zoom, it seems like there were a lot of people who were talking and maybe unmuting. Well, now we're able to run it over here instead. By the way, I'm going to adjust this. So this is going back to the usual levels that I use when I do the YouTube. Excellent. Well, welcome. I do want to get a sense of how many people are here. So we currently on this, we have actually gotten to 99 people who are now on our YouTube, 100, and that's close to what we were looking for. And let's go ahead and start. So we're going to be able to do this we'll do it for about 1 hour as we talk about some interesting math problems. At the very beginning, I do want to mention, since some people didn't get to hear the beginning of the Zoom call, our goal here is to not just do a math class, but also to answer some questions in case you might have some questions about math or math competitions. And we have chosen questions from the AMC. But this A is the American math competition because we understand that there are many people from your community who have already done many of the Australian math competition problems. Well, let's go ahead and get started. So, somebody asked, what happens if someone gets an ad? Well, there are no ads. In fact, if you have noticed, we happen to have a YouTube channel which has 0 ads, and it just focuses on the mathematics. The first question of today. A palindrome is a number that has the same value when read left to right, or from right to left. For example, 12321 is a palindrome. Let n be the least 3-digit integer, which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? What a strange question. Well, when you look at this, the thing that pops out into my eyes is 2-digit palindrome. What's a 2-digit palindrome? Can anyone tell me? This is what the chat is for, you see. If you have an idea, what's a 2-digit palindrome? There aren't many choices, right? If you want a 2-digit palindrome, there's like 11, 22, 77. Actually, 2-digit, oops, just a second, let me save that. Actually, 2-digit palindromes are really trivial, are really simple. There aren't many things that could be 2-digit palindromes. It's just 11 times something, double the same digit. So every 2-digit palindrome is equal to 11, not 17, 11 times something. So this is a nice question. I think we can solve this problem. If I have to add together 3 distinct 2-digit palindromes, then the sum of the 3 distinct 2-digit palindromes is always a multiple of 11. So if I want to know what this is always going to be a multiple of 11. Now, the next part of the question is I have to have that there's a least 3-digit integer. That's the sum of this stuff. So can you tell me anything about a small 3-digit integer that's a multiple of 11? I wonder if you guys can figure this out. Well, here's a 3-digit integer, 100, but that's not a multiple of 11. What's the first multiple of 11 with 3 digits? 101. Is 101 a multiple of 11? 99 is. But 110 is the next one. 99 is 11 times 9. 110 is 11 times 10. So, for example, our first question is smallest 3-digit multiple of 11 is equal to 110, which is 11 times 10. And I do need to check, is it true that this is not a palindrome, right? You got to read the problem. And I have to make sure that this number is not a palindrome. Yeah, it's not. 110 is not 011. And the next question is, can I make it the sum of 3 distinct 2-digit palindromes? That's where the 10 is useful. Can I make 10 the sum of 3 distinct numbers? Well, yes, you can. You can write this as 11. Let's do this way. This is equal to 11 times, instead of writing 10, let's write 1 plus 2 plus 7. Let me tell you why I started with 1 and 2. It's because I want to make it the sum of 3 different palindromes, and it's easier to do that if I use the smallest ones. Then I run the smallest risk of crashing into myself. And yes, then it works. This is equal to 11 times 1 plus 11 times 2 plus 11 times 7. Hooray! So the answer to this question then is 110. We're done. No. Always be careful. Don't get too excited. The answer is not 110. We have to read. And it says what's the sum of the digits of n. And so the way you solve all these problems is you have to not get super excited that you solved it. You have to read the question. And the question says the sum of the digits of n. And the sum of the digits of n is going to be 1 plus 1 plus 0. And that is equal to... Oh my gosh, you guys came all the way to a live stream to learn about 1 plus 1. And that's 2. Okay, that's the answer to the first question. Next question, what's up next? By the way, in the American math competition, there are 25 questions. Question 13 is somewhere in the middle. Let's see what we have next. American math competition questions are often quite long. What's this about? Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she will redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realizes that no circled date falls on a Sunday. Now that's good. On what day of the week does Isabella redeem her first coupon? When I look at a question like this, I always get scared because there are dates, and when there are dates, it's Sunday, Monday, Tuesday. What if I get a day wrong? What if I'm off by something? But I also see 10. Who cares about 10? I care about weeks. 10 is not anything interesting. If I only care about weeks, can someone in the chat tell me a number that I should use instead of 10 that will have the same answer? 10 is a big number. I don't like big numbers. 3. Thank you very much, Heidi Ni. Use 3, because if you have 3 days versus 10 days, it's not going to change the day of the week. So let's first of all change the 10 into a 3. 3. Okay. The next thing is it looks like I'm going to have to think about what happens as you circle days. Here's how I think of a question like this. I don't want to draw a calendar. Instead, I want to draw a circle of days. So what do I mean? I'm not circling days. I'm going to draw a circle of days. The circle of days looks like this. I have Sunday. I have Monday. I have Tuesday. I have Wednesday. I have Thursday. I have Friday. And Saturday. Now, why would I write a circle? The reason I write a circle is because, you know, after Saturday is Sunday. So the days kind of go in a circle. It's sort of like a clock, except some crazy person decided to only put 7 things on the clock. Now, what's the deal with 3? When I look at this problem, I go and backtrack, okay? I see that this Isabella is circling 6 dates, and no date is Sunday. But there's something nice about the number theory. If you're going by 3 every time, meaning like suppose you've just circled Tuesday. Suppose you just circled Tuesday. Let's ask the audience. Suppose you just circled Tuesday. See, that's a circle. What would I circle next? What's 3 days after Tuesday? Well, you look at the clock. 1, 2, 3. So if you circle Tuesday, the next one you circle is Friday. Does that make sense? If you circle Tuesday, you'd circle Friday next. Now, there's something useful about 3. When there are 7 days in the week, 3 and 7 have no common factor. And since they have no common factor, that is why you actually would go through all 7 days if you tried to keep adding 3 and adding 3 and adding 3. In fact, I can even draw a little chart. Watch. If I was on Tuesday, the next one I'd circle is Friday. Does my arrow make sense to you guys? I'm saying that if you circled Tuesday, then you'd circle Friday next. And if you circled Friday, what day would you circle next? The next day you'd circle is Friday plus 3, which is Monday. Is it okay? Monday. And after Monday, what would I circle next? It would be Monday plus 3. Tick, tick, tick. It would be to Thursday. Okay? After Thursday, Thursday plus 3 goes up to Sunday. By the way, I'm not trying to instantly tell you the answer. I'm trying to show you how you'd think of the method. Right? And there is actually a very fast way to do this. We'll see the fast way at the end. But what I wanted to show you is a beautiful picture. It looks like a star. From Sunday, what's 3 days after Sunday? It's Wednesday. And 3 days after Wednesday, tick, 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 Saturday. 3 days after Saturday, tick, 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 Tuesday. It's actually really pretty. Math is full of symmetry, and what we just drew is a symmetric 7-pointed star. Twinkle, twinkle, little star. So we've got this thing here, and this is what would happen when you keep adding 3. But there's a very important thing to notice, which is the number theory. You see, there were 7 days, and I went by plus 3 every time. 3 and 7 have no common factor. No common factor. And we talk a lot about this in the number theory class. But when you have 3 and 7 with no common factor, they're relatively prime. That means that you'll actually go through every day. And that's where, this is the shortcut now to do the problem. You see, she circles 6 days. But there are 7 days. And so if 6 of the days get circled, that means that the day she's about to circle next is Sunday. So this is a very key idea. I see some people are saying the answer is Wednesday. The reason the answer is Wednesday is because there's one date which is not circled. See? It's squared. I mean, it's just a bad joke, but I'm saying that's not a circle, okay? That's not a circle. She circled every other date. Every other day has a circle. Of course, she's circling them on a calendar, not on this nice chart. But she's circling them on the calendar, and there's one which is like not circled. But that's how you can tell where she started. You see, because if the Sunday is in the square, then where did you start? Now you can all see she has to have started on Wednesday, because this is like a 7-pointed star that's like all looped together. If the 7-pointed star is all looped together, the only way that you can have one of those days not circled is if that day was at the end, like it was in between. You see? So exactly, somebody mentioned they told you it was Wednesday. Yes, but the way you know it's Wednesday is because Sunday is the place where you didn't get to. So that means that you must have started right after Sunday, that's the Wednesday, and then gone zoop, 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 and stopped at the day right before Sunday. And now, if you want to know the shortcut, the way I did this problem is when I saw the problem, I said, oh, don't use 10, use 3, because 7 days is a week. 3 and 7 are relatively prime. They have no common factor. Aha! Then all I need to know is, because the 6 dates are going to be all the dates except Sunday, that's how in my head I knew that this person was going to have stopped right before getting to the Sunday, and that means they started right after the Sunday, so I would just have used Sunday plus 3 days, get Wednesday right away. So that's the shortcut to do the problem, but this picture shows why it works. All right. Any questions, by the way? I should actually ask. This is supposed to be interactive, and we do see people are able to ask in the chat, so I'm happy to answer questions. If not, let's continue. Next question. What's here? It's one of these problems. Qiang drives 15 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? I don't actually know what you guys use in Australia. You might use kilometers, but because the A is for American in this particular AMC, everything happens to be in miles. But all you have to think of is miles is just distance, okay? Unless you guys also use miles. Well, so this one seems okay, imperial units. You know what? Maybe at some point you guys also used miles at some point long ago. But let's do this problem. When I see this, the thing I always get worried about is, oh no, what if I divide by the wrong thing or multiply by the wrong thing or keep track of the wrong thing? So here's a hint. Organize your scratch work. What I'll do with my scratch work, oh, I see, somebody's asking where I am. Am I in Australia? No, I am in Pittsburgh, Pennsylvania, in the United States of America, on the east coast of the United States. All right, so when I do this kind of a problem, the first thing I want to do is I want to keep track of what's my distance, what's my time, what's my information. Well, if I have this total information, the information is I have the entire trip, then I need to think about the entire trip. I probably need to write down what is my entire distance and what is my entire time. Let's try that. What's my entire distance? Oh, and another thing, before I start doing this, there's a question it's asking, how many additional miles? You remember on the first question I did here, I got super excited when I got, this answer of 110. And I was warning you, don't just write down that answer. The important thing is to also protect against silly mistakes by defining your variable x to be exactly what the answer is supposed to be, so that when you get super excited, you say, well, yeah, it's x, and I'm done. So x should be the number of additional miles. So additional miles, that's going to be x. Okay, now in terms of x, let's try to figure this out. Entire distance. Well, 15 miles, that's easy. It starts with 15. Plus, how many additional miles? Oh, this is so easy. Just 15 plus x. I don't have to do anything. But the next thing I have to do is I need to go and say, how many additional miles? Well, I need to know about a time because I have 50 miles per hour for the entire trip. So what's the entire time? The entire time. Now I need to start to think. If I have 30 miles per hour, is it just like 30? No. You have to put together the 15 and the 30. So if you're going 15 miles at 30 miles per hour, how do you think of this? The way I often look at it is I say, well, in 1 hour I would go 30 miles. In half an hour I go 15 miles, right? It's half. And I can also do it as, if I wanted to do it slowly, it's 15 miles divided by 30 hours. No, wait, no, that's not what I mean. It's 15 miles divided by 30 miles per hour, okay? And that's also half an hour. By the way, the reason I told you this thing about the double check is that it helps to make sure you don't just make a silly mistake. So by looking at this, I was like, yeah, that makes sense. 15 over 30, half. Next thing. Oh, yes. And what should the next thing be? Yes, thank you very much. The time is plus. Now you go, oh, which way do I divide? Is it 55 divided by x, or is it x divided by 55? If you're ever not sure, let me show you how to make sure. The way you make sure is, if I did, let's try 55 divided by x, what would it be? It would be 55 miles divided by, no, not 55 miles, 55 miles per hour. Miles per hour divided by x, miles. And if you do that, what you'll get is you get 55 over x, 1 over hours. What's a 1 over hour? I've never heard of a 1 over hour. That's not a unit. Actually, it is a unit. It's 1 over hour is something like, let me think for a second. If I wanted to convert into hertz, hertz is 1 over second. And so if I want to go from hour, 1 per hour, that's really slow in hertz. That's 1 over 3,600 hertz. But that's physics now. And as you can tell, I actually love all subjects. I can talk about math, I can talk about physics, but you guys came for the American math competition problems, so I won't go further on that. Instead, when I go here, I'll say, this is 55 over x, wrong units. And that also tells you if you flip them, if it was x over 55, x over 55 is going to be in hours, and that's the correct thing. Okay? So this will be x over 55. And if I wanted to know, this is in hours, and the other one is in miles. Perfect. Now I can think about what it means to average 50 miles per hour for the entire trip. If I want 50 miles per hour for the entire trip, then what multiplies by what? Well, it's miles per hour, right? So then you should just divide the whole thing, and it should be 50. That's a nice way to look at this. If you divide the whole thing, if you were to divide the whole thing, that'll be miles per hour. So what that means is the entire speed is going to give you an equation, 15 plus x, divided by 1/2 plus x over 55. That's equal to 50 miles per hour. At this point, it's just a matter of solving equations. And this is where you're careful, right? You be careful, and then once you're careful, you just solve. And so I guess I'll multiply by the denominator onto both sides, and I'll get 15 plus x equals, if I multiply this piece up, I get half times 50, which is 25. Let's write the 5 in a more pretty way. 25 plus x over 50, not x over 55, this x over 55 times 50. What's that? X over 55 times 50, that's equal to 50 over 55. Well, let's do it this way. X over 55 times 50. This is a times 50. By the way, the reason I'm doing this a bit slowly is I want to make sure that this live stream is understandable to as many people as possible. There will be a hard problem coming, and that hard problem will challenge everyone. But I want to make sure this is as understandable to as many people as possible. I want to simplify this. Also, I want to show you how you can think about this to be as careful as possible, not to make mistakes. When I see numbers with 5s in them, well, common factors in them, I cancel first. 10, 11. So now, let's go and write this whole equation over here. So now my whole equation is just 15 plus x is equal to 25 plus 10 over 11 x. This is where I get happy. The reason I get happy is if I have 10 over 11x and an x, I can subtract the 10 over 11x to this side. I just get 1 over 11x left equals, and if I subtract 15 from both sides, 25 minus 15 is 10. And we get the answer that people have been writing. X equals 110. And that's the answer. And this is how you do these things as carefully as possible. For those of you who already knew this stuff, I'm talking about this slowly to help you reduce your mistakes. For those of you who didn't know these things, I hope that this thing made sense, that this explanation made sense. And thinking about these units helps you not make a mistake. Next question. What's this about? A tournament. In a tournament, there are 6 teams that play each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. Makes sense. After all the games have been played, it turns out that the top 3 teams earn the same number of total points. What is the greatest possible number of total points for each of the top 3 teams? When in doubt, take a sip of water. Well, when I look at this thing, okay, I actually had done the problems before, but I was just trying to indicate to you a nice thing to do, especially if you're doing a contest. You might be thinking, and don't forget to stay hydrated when you're doing a contest. If you don't drink enough water, your brain can also have difficulty thinking as clearly. But when I look at this thing, I say, how many teams are there? There are 6 teams. If there are 6 teams, and I seem to only care about the top 3 teams, right? I see this word yelling at me, greatest. Greatest means I want to help these 3 teams, and I don't care about everyone else. So if I want to care about the top 3 teams, what it looks like is that there's the top 3 teams, and I guess there's the bottom 3 teams, other 3 teams. Okay, so I've got the top 3 teams, the other 3 teams. Let me tell you how I think of all of these things in my head. I often think of them as like dots. Because they're like, that's where they're standing. That's these teams. The teams are in lumps. And so I have these lumps over there, those lumps over there, and they're playing some games. And if I think about it, I have each team playing each other twice. Okay, if I care about giving lots of points to the top 3 teams, I know what I'll do. I'll just make sure that they beat the other 3 teams. I guess we don't care so much about these other 3 teams' feelings for the sake of this problem, but we're just going to make these beat all of those, okay? And if I want to think about how to draw this, I often think of like an arrow of being like, I beat you. So this one here, beat. Right, so my arrow means that this one here beat that one. This one here beat that one. So they're all beating this way. And actually something about this problem is that, oh, that's a lumpy line. Let me try to draw it more straight. Using the correct angle to draw a line sometimes helps. But remember that they actually play 2 games. So in fact, I want to say beat it twice. Okay, beat it twice. I just made up this diagram, but this is my way of trying to draw it. So these things all beat that way. By the way, I want the same thing here. Each of these 2 also, same. They all beat this way. But then the question now says, how should I organize this? I want to have these teams have lots of points, but actually the top 3 teams have the same number of total points. So then the question is, what to do with these 3 teams amongst themselves? Beat them up. Well, you should be careful because I need to have these 3 teams have the same number of points. So if I want to do that, the way I would think of this is, well, I should first try to be as greedy as I can. The way to be the most greedy is to say, all these top teams, they definitely beat the others, okay? So it's still like same. The same kind of picture going across. But now I need to know what's going on in here. Is it possible to draw, right? That must be it. They're supposed to be friends, right? These 3 teams have the same number of points, so maybe let's have them all draw. But that would be too easy, and that would be wrong. The reason that's wrong is because look at what's going on with the draw, okay? If you had 2 teams that draw, each team gets 1 point. 1 plus 1, we've done that today before, 1 plus 1 is 2. But there's another way that you can get more points. Remember, the teams play each other twice. If the teams play each other twice, why not do this? Meaning that when they play each other, they take turns winning. Think about it this way. If you take turns winning when you play each other, you each get 3 points. On the other hand, if what happens is you draw and then you draw, you get 1 point and 1 more point. 1 plus 1 is only 2. Did that make sense to people? This is actually the trick part of the question. The way to know that this would have been a bad thing to draw is you look at it and you say 3 points for a win and less than half for a draw. Less than half of the 3 for a draw. So that's how you know that the draw is bad. It's not a good deal, right? So that would give each person 2. So in that case, what you do instead is, let me draw this in a way where I can even make it look like a triangle. You want it to go where they take turns beating each other. Like this. Did that make sense? So what I've just done here is they take turns beating each other. And when you look at this, yes, all of them will have the same score because each of them beat the same number of people. And now we just count. How many beats did we have? Well, this person will actually beat each of those once. So it's 1, 2, 3, 4, 5. But you have to be careful. Each of these is a double. Be careful of the double, right? Because this thing means it beat this team twice. So you go 1, 2, and then plus 2 is 4. Plus another 2 is 6. Plus another 2 is 8. So I have 8 victories, and each victory is worth 3 points. So 8 times 3 is 24. Did that make sense? So the answer is actually 24. Each team in the purple, in the pinkish purple, each top team wins. I'll do it this way. I actually hate counting. It wins inside this group. It beats everyone except itself. And there were 3 there, minus itself. And then it does double beating across to the right. This is actually how I would think of it. This is how I make sure I didn't make a mistake. Pinkish purple, indeed, says cheese. So this is 2 plus 6, which is 8. Which is 2 plus 6, which is 8. And then the score. The score is the 8 times 3 because it's 3 points for a win. And so the score is equal to 8 times 3, which is 24. And that finishes this question. Any questions? Does anyone have any questions so far on this problem? If not, let's go on. So the next question that I want to do goes to a percentage question. A store increased the original price of a shirt by a certain percent, and then decreased the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? These questions are quite standard. Actually, the way you think of this is you say, it's going to increase and decrease by the same amount. And so oftentimes the way I think of that is, let's call that amount x. But when I say call that amount x, I'm thinking of x as a decimal already. You know, if somebody says, I have 10%, that's 0.1. And the important thing to use here is that if you increase by a certain percent, what that means is that you multiply by 1 plus some unknown x. That's actually a very useful thing to do. Whenever you want to increase the price of something by 100%, you do multiply by 1 plus 1, because 100% is 1. So this is useful, okay? And if you want to decrease by a certain percent, I guess we'll use pinkish purple. If you want to decrease by a certain percent, then you multiply by 1 minus that percent. Let's draw that a bit better. 1 minus that percent, right? And so I just need to open the brackets. And if you open the brackets, the beauty of doing things this way is you just multiply. And so if you first increase and then decrease, you multiply by 1 plus x, and then you multiply by 1 minus x. So the total effect. People are saying, you can use dots. You're right, I can use dots. But I often like when I teach to write like tiny x's that look sort of like dots, but you can still tell that they're multiplication signs. Okay. Oh, you mean dots meaning difference of two squares. That's really interesting. In America, we don't call it that way. But it's totally difference of two squares. So the net effect. I love it. I've just learned something new. DOTS. That's great. Net effect is you multiply by 1 plus x multiplied by 1 minus x. And when you expand that, it's a difference of two squares. It's 1 times 1. Okay. And then the minus x and the plus x cancel. So I don't have to do anything. And then it's a plus x times a minus x, which is minus x squared. Okay? So it's 1 minus x squared. And that's the net effect. Well, the net effect is 84%. So the 84% is the same as multiplying by 0.84. Right? The resulting price is 84% of original. So now I know that 1 minus x squared is equal to multiplying by 0.84. This makes me happy. The reason this makes me happy is because I see a 0.84 and I see a 1. I can subtract. So 1 minus a 0.84 is just 0.16, right? So if I subtract that, I get 0.16, and that's equal to, add the x squared to both sides, x squared. Now I get even more happy, because 0.16, I know what that is. That's 0.4 squared. So x is equal to, well, strictly speaking, it's either plus 0.4 or minus 0.4, but, oops, just a second. It's either plus 0.4 or minus 0.4, but the situation here is that we already know that you increased the price by, you increased by 0.4, so it better be that way. And that's 40%. So we get an answer of 40%. Excellent. So now that brings us to the last question that we're going to talk about today, and then we'll leave some time for questions and answers. The last question is a geometry problem, and this is one of the hardest problems on this last year's AMC 8, which was the American Math Competitions. I have a triangle, ABC. Point D divides the side AC so that these have a ratio of 1:2. Now, E is the midpoint. It's halfway in between, so that's why these two are marked equal. And F is just this point right here. Now, you know that the area of the whole triangle is 360. And the question is, what's the area of EBF? Where is EBF? Oh, there's the E, and there's the B, and there's the F. I see. So we need to know what's the area of that thing. Now, let me tell you why this is a hard question. The reason this is a hard question is we don't have enough information, do we? Well, of course we do, because the problem is solvable. But when we look at this, so good. I like that some people are thinking, because this is going to be tough. And actually, our moderator, Debbie, has made a comment. But I'm going to show you a sneaky trick that solves this problem like a lightsaber, which is like a unfair trick. Okay? But first we'll try to do it without a lightsaber, with like conventional weapons. So if I know that AD to DC is 1:2, what can I do with that? So this is like, well, it looks like it. This is double, right? Whatever this is double of it. Could we do something with areas? That was the first thing that I thought about when I saw this question. Because you see, if I draw another picture, let me see if I have another picture. I'm curious. I do have another picture. So if I have another picture, well, the area of the whole thing, the whole area is equal to 360. Okay? Now, if the whole area is 360, now the area should also cut by 1:2. What I'm doing here is I'm going to focus on two triangles. One triangle is here, and the other triangle is here. All right, I've got these two triangles. I'm not sure you can tell. I have a better idea. I have another pen on this, which draws really, really big lines. Actually, I wanted to use a different color. Let's use that's the blue. Like this. Okay? So I'm interested in these two triangles. Yes. So I can have somehow these two different triangles. We're good. And you can see I'm focusing on two of them. And if the whole area is 360, remember that the area of a triangle is half times the base times the height. And what do I mean? I think of this as the base. AC is the base. Right? So if I have this as my base, and I think of a height, and the height is like going to the B, if you look at the triangle, which is on the left side, this triangle here has the same height as this triangle, if I'm thinking of this guy as the base. Does this make sense to people? This is my base, and for both of these two triangles, they actually have the same height. And since they have the same height, then the ratio of their areas, the area of this to the area of that, since they have the same height, the ratio of their areas is the ratio of the base lengths. It sort of makes sense, because this base is twice as long as that base. So the area of this triangle is twice as big as the area of this triangle. But the whole area is 360. So good. I see that Vanessa and Amber is saying, so ABD is 120. Because I have this 360, and the 360 needs to be split into something and double the something. So I have 120 for the whole thing there. So how am I going to do this? Oh, I get it. I will delete this part. I'll also delete this part. And I'll use this guy again and highlight just this piece in green now. And that one is 120. Okay, so that one is 120. Oops. I want my green. Give me my green back. This is 120. And the other one, let's go ahead and use blue. Okay, blue highlighter. And this one, in the blue, is 240. Are people okay with that? So that's because they both had the same height. And therefore, if I look at the ratio of their bases, I should find the ratio of their areas. Okay, so now I have 120, I have a 240. So what? I saw that somebody else in the chat said something very interesting. You focused on that 120. And you said, if this is 120, let's use the same trick. You see this thing here? These two are both bases of a triangle they're both bases of triangles. And the big triangle and the big triangle here happens to have an area of 120. And these two little triangles have the same height. So that means that somehow this is equal to this one. Does that make sense? This has to be this area is the same as this area. So that means I can break the 120 into 60 and 60. Okay? So far so good. So now I know that this is 60 and this is 60. And this is where you get stuck. We're stuck. Now what? Unfortunately, the question asks for that thing. Who cares about that thing? Oh no. That thing? How are we going to get that thing? It's no good. In fact, this problem is really interesting. I like this problem a lot because it's quite hard to do. But it's quite, well, one way to do it is what our moderator, Debbie, said, which is to pretend that the triangle is equilateral, write equations and intersect them. But I'm going to show you a crazy technique. You see, what I want to show you is we just got stuck. You actually can't finish it easily from here. Because, what's that? How would I finish it? Drink more water. Well, no, water won't help. I'm going to show you a trick. This trick has a name. And if you're curious about this, I encourage you to go look it up later, and you can find entire stories about how to use this trick. This is a trick that's not taught to many people. It's called mass points. Okay, we're going to use mass points. Actually, I'm now curious. Since we have the audience from Australia, and we have a lot of people who are watching, have any of you actually learned mass points in some class before? It's often taught in some fancy trick class. And I'm just curious. I mean, these classes are in the US. The US will teach about mass points. I'm curious whether anyone in Australia has ever learned the technique of mass points. I see a lot of no's. And that's interesting. Okay, let's talk about this. Let me tell you where I learned it. The first place I ever learned mass points was in a textbook that I learned geometry from in the United States. And it was something which people didn't cover normally in the geometry class in school. But here's how it works. You pretend that you put, so this is a legit drawing, okay? This is a triangle. The triangle is made of paper. I mean, like really stiff paper, okay? It's made of really stiff paper, but it's actually like cut out. You can cut it out. So you cut out this nice triangle, and on A and on B and on C, what you do is you're going to dangle some really heavy things. This is sort of like a mobile. I don't know if this is how you call it in Australia. In America, a mobile is like something hanging from the ceiling. And it comes from the ceiling, and there's like some string, and then there's some nice thing, and then maybe there's like some more things hanging down, and they're heavy. Have you ever seen stuff like this before? I don't know. It's a decoration that people like to hang from the ceilings in the United States. Like somehow you hang something, and then you have some lines, and the heavy things, and if the wind blows, the thing might move, right? Here's how to think of it. This is a mobile now, and we're dangling from E. Okay, so there's something, the way you should think of this is a mobile where if I went to draw the triangle would look something like this. I'm going to attempt to draw some 3D picture, okay? It would look something like this, and there would be something coming from above, and there would be some things going below. Does this make sense? And then these would all have like some lumps. And I'm imagining that you just took this thing and you're stringing this up from the ceiling, and the E is exactly where this string touches, but it's perfect. Imagine it's perfectly flat. Okay, so this is perfectly flat. Perfect balance. Flat. Okay, so here's a question. How much mass should you put on each of those? That's why it's called mass points. So if I want to dangle it where the thing dangles on the E, I will put some masses down. And if you want it to balance, there's something very important that's related to the center of gravity or the center of mass. This is physics. It is called a mobile, so it is called a mobile. And the trick here is if you're trying to, and the trick here, sorry, right? If I'm trying to actually balance this thing, and if I want to have it all balanced where the thing is hanging from the top, there's something about the ratio of the two masses that you put at A and at C. It's related to levers. So for a moment, let's not talk about the let's not talk about the triangle. Let's imagine that I have a much simpler mobile. The much simpler mobile is just a string coming down and just a stick But the stick happens to be that this is double of that. So it's like in a ratio of 1 is to 2. Okay? And then there's some strings hanging down. Strings weigh nothing. And they got some lumps. Can anyone tell me how you should balance the lumps? If I want it to balance perfectly, so I want this thing to hang from the ceiling, and I want this stick to be across, but it's 1 here and 2 there, what do I know about these two masses if I want it to be balanced? It's like a seesaw. They shouldn't be equal. If I have these two be equal, if these two are equal, you may have done this with a seesaw before. If they're equal, this one's going to go down, and that one's going to... No. Sorry, other way around. If they're equal, this one's going to go down, and that one's going to fly up. Is this math or physics? Well, actually, this is the math behind the physics. Right? Sorry. Yeah, you're totally right. So if these were two equal ones, whump. So you actually need to have the heavier one closer. Okay? And this is the basics of a seesaw. What you would want is that this is double the mass of that one. Okay? So this thing here is double the mass. But something else that's useful is you only care that it's double the mass. You see, there are many ways that I can make this balance. One way to make this balance is if I put 2 and 1. That would balance. But it would also balance if I write 20 and 10. Do you agree? As long as this is double of that, we're good. Okay? And so this is both math and physics at the same time, but that's because math is very deeply related to physics. Now I'm going to go up to the triangle thing. Suppose I wanted to dangle from E. Can you tell me anything about how the masses of A and C have to be? The important thing is that if you're dangling, and this is made of paper, like some strong, infinitely strong and infinitely light paper, okay? If you have this thing dangling from E, and the only mass from this thing is from the A pushing down and the C dangling down, the A and the C dangling down, I'm about to make a statement about the ratio of the masses at A and at C. Even if I don't know anything about B, if I don't know anything about how heavy is the thing at B, the fact that I'm dangling it from E, and this is a line that's going through, right? I'm dangling it at E. If I'm dangling it at E, since B is on this line, B doesn't contribute to the balance. Maybe let me do it this way. Okay, this one might have been confusing because somehow there was this triangle here all of a sudden. The more important thing is to think about this. Imagine that what I'm dangling from is I've got this point E. Okay, E is here, and E is where the dangle happens. And I have some line which is going through. This is a line that's on the paper. That didn't look straight enough. Got a line going through the paper. And you know, there's going to be some mass dangling here. Dangle. Whoa, something. It was like these 4th of July or something. But so something is dangling here. The United States just had the 4th of July, and so some people still had some fireworks, I think. But so this is dangling here. And if I have something dangling here, but this is a straight line, now what happens next is if you have a straight line here, and you have something dangling from here, and something dangling from here, but they're the same distance. If these were the same distance, then in fact, if I want to make this all balance, I would put the same mass on each of these. So what I'm emphasizing is, if I had only, so this is like my sheet of paper, okay? And I dangle from E. If there's one place I'm dangling from, and I draw that straight line across, and if these two are the same distance from it, it's not going to make the thing wiggle. Okay, how do I do this? It's not going to make the thing wiggle like this or like... This is always hard for me because the whole thing is flipped. But let's go here. It's not going to make the whole thing wiggle this way, right? I'm afraid of wiggling this way. But it's not going to wiggle that way because if these two were the same, you could imagine that this is not going to help make it do any of like this kind of wiggle because it's just on here. The only this kind of wiggle you have to worry about is from these two. Remember, this is a completely flat thing. And so this piece is completely flat on top. Since it's completely flat on top, I actually need that. If these two were equal distance, then they're the same. But now what if they're a little bit different distances? Well, first of all, if they are the same distance, but like a little bit off like this, oops. If I had still the same distances, if those two were the same, still equal weights. All right? But the interesting thing is if I start making one distance farther away, it changes. And so what's actually going on here is this thing is going farther away. If it's going farther away, and this is twice as far away from this balanced line as this one, the mass that I need to dangle on here is only half of the mass I need to dangle there. So what I've just done is I've been explaining the basic principle of mass points. Mass points is a technique that you can use when you write some numbers down and it looks like magic. But I was trying to explain why I'm writing a 2 here and a 1 there. Okay, I'm going to take a moment. Why you write a 2 here and a 1 there is because if I wanted to balance the whole thing dangling from E, I won't worry about B for a moment. I look at this line that is going along, and since the A is half as far as the C is from that line, then the amount of mass I need to balance is double there and only 1 there. The next thing you do is that the next piece of mass points is you say, I'm going to put 3 numbers. I don't know what's here yet. It'll be something. But here's what I'll do. It'll be something else, and it'll be written inside a circle. There's going to be a number inside. It's not 0, okay? It's not 0. These are the 3 main masses. But something else I can do is I can say, you know, if I want to figure out what I need to put there in order to make the whole thing balance, the next thing you can do is you can imagine that this mobile, actually, remember the paper has no mass, right? The paper has no mass. So I just have this thing sticking here, and I have a stick which is going across this way, and a stick which is going across that way. So imagine that for my mobile. Now my mobile, I'm making my mobile with just 2 sticks. That's reasonable. You've seen mobiles like that before. You hang this from the ceiling, 1 stick, 1 stick. And that's the same kind of balancing because I said that these sticks weigh virtually nothing and it's just like a skeleton for the paper. But if I did that, here's what you do with physics. Look, if I have this stick here which is balancing and it has a total mass of 2 there and 1 there, that's the same effect on this stick as if it just had a mass of 1 plus 2, which is 3. And that is not the kind of pen I wanted. The 1 plus 2, which is 3. And I'll draw that in a square. So what I've just done is I've just explained that if I have a 1 and I have a 2, what you write in the middle is a 1 plus 2. Okay? And what the 3 means is if I was hanging a mobile sticking from the E, then if I want to know what to put there, it's as if I can ignore the 1 and the 2 and I just have a 3. And that tells you what you should put here. You see, these are equal distance. If I had a mobile with a string hanging from the E, and it's equal distances, and that's 3, what should go there? Can anyone tell me? If I'm trying to balance with a mobile, string hanging from E, equal distances, one of them has 3 as a weight. If I wanted to balance, that's also 3. Exactly. So if that's 3, that's 3. Wait, now this is exciting. Because now remember, this was a paper. I just drew a skeleton being like if that was the backbone of the paper. But the paper is, you know, no mass, and my skeleton I can think of in a different way. I can also think of my skeleton this way. Oops, let me go and get the highlighter. This way. When I say this way, what I mean is, if I'm hanging from here, let's pretend that my paper skeleton, I just made this way instead. It's the same because I'm still supporting these 3 dangling things. Now what I'm about to say is, from the point of view of dangling from E, if I just had this stick and this stick, let's ignore the 1 and the 3 and put a mass here. What should be the mass here? So what I mean is I'm writing a number on every single letter. And I'm saying that, imagine I'm dangling from the E, I have a weight of 2 there. I don't care about the 2. But it's supporting a stick which has a 3 and a 1. So 3 plus 1 is 4. That's the idea. Because if I'm dangling from the E, and I have this stick, which has a 2 and something, and then on the other end there's a stick with a total of 4, then the natural thing to write here is 4. Let's go back to the pink. 4. Okay? And now, when I wrote this 4 here, now I can tell you what is the ratio of the lengths, the EF to the AE. You see, because if I'm thinking about this stick pattern, the whole thing was balanced, right? So if the whole thing's strung up from the E, and there's a mass of 2 there and a mass of 4 there. Can you tell me anything about the relationship between this length and that length? 1:2. That is the most powerful observation. So I've just managed to find out that this length to that length, this is 1/2 of that. So now I can actually solve the problem. I used this mass points technique to find out that this piece is half of that piece. If that's true, remember that this was 60. Let me write it in an easier way. 60. This whole thing was 60. And now I have 1:2. If that's the case, I can tell you the area of this triangle now. Because I have base, base, and same height. I'm using that trick over and over again. So base, base, same height. And if this base is twice of this base, and they have the same height, then the area of that 60 thing is twice of the area of this thing. And that gives me 30. And that's the answer, 30. Okay, now, I was explaining to you this whole thing in slow motion. Here's how you do it quickly. If you knew what mass points meant, here's how you do the problem really fast. Let's go and get a clean sheet. This clean sheet. This is how you do the problem really fast. Oh, 1:2. Okay, so we'll put the masses in the opposite ratio. Okay, 2 plus 1 is 3. Oh, it's balanced. So if there's a 3 here and it's balanced there, then that's got to be a 3. Oh, 3 plus 1 is 4, so I can put a 4 there. Now, if that's a 4, then the ratio of this to this is half. This is like 2:1. And that's how I'll solve the whole problem. Because then I'll do the same thing I did at the beginning, which is, okay, well, I've got this whole piece. This is 360. If this is all 360, then this part is 1/3 of 360. Actually, I can tell you what I would do to solve this problem. I would be like, well, the whole thing is the 360. This part is 1/3 of the 360. So far I got 1/3 of the 360. We're just retracing what we've done. This is 1/3 of the 360 is 120. Now from that 120, half, so I get 60. And then, because of the ratios, 2:1, half of 60 is 30. And that finishes the question. But this technique is extraordinarily powerful. What I wanted to do, why this was so long, is because when I learned mass points, somebody just told me, if you see 2:1, just write a 2, just write a 1, just add them up and put it there. If you see this thing, like put a 3 here, put a 3 there. And then just like add stuff, like, 3 plus 1 is 4. If you ever see a line, add them and put the number there. That's how I learned mass points. I had no idea why. And what I just tried to show you is the way that you'd understand why. The way you understand why is you imagine that this is a mobile, except that the mobile is made up of like these sticks that have no mass. And if you think about the sticks, you can figure it out. Okay? Well, that finishes today's math class. I hope that was somewhat interesting to you. We did a number of different problems, ranging from like relatively doable to something which is a very powerful technique that it appears that nobody on this chat had seen before in Australia. I know we started a bit late, so I'm willing to stay a little bit to answer some questions. And I apologize for the chaoticness getting started of switching between the different rooms. So yes, this was for an hour. And this was the special live stream for you guys. We care very much about the Australian audience here. So I'm kind of curious. Do you have any questions you want to ask me? They can be about anything. They don't have to be about like math anymore. And parents, you're welcome to ask questions if you have about like learning or these kinds of things. I'll stick around for a few more minutes. I actually feel bad for starting late. We shouldn't have done that. And yes, if anyone's wondering what time it is here, it's just past midnight. But you also don't need to worry about that for me. Some of you, if you ever watch my normal live stream in the United States, you will know that I've been working on like some crazy things to try to stop the spread of COVID-19. And so I usually go to sleep quite a bit after this anyway, every night. Okay, so yes, why does mass points works? Because of what I just showed you. This idea of the sticks and the mobiles. The only key idea you need to think about is make a mobile. Oh, that would be useful. Try making a mobile. if you just make a mobile and try to balance things, you'll see why it works. And if you're curious, you can read some more. I see some questions people ask like, oh no, Yoink in gaming, what's IQ? What's my IQ? I have no idea. I don't believe in those things. I think that doing these math problems is a better measure of intelligence. And so I've never taken a single IQ test. It's not very interesting. So I have some other kind of questions. Somebody has asked for my address. My address is, it's in the United States. You can in fact find out where I'm streaming from, because if you just look for our app, which is the one that's trying to stop the spread of COVID-19, the app is called Novid. It's COVID with an N. And if you look at Novid, you'll find out Novid's address. That's where I am right now. More questions. So Shirley Wu, how do you improve on solving harder questions like the ones on exams? So today's stream, what I tried to do is I tried to show you some questions which were not necessarily as hard, but very easy to make mistakes. And I showed you ways to not make as many mistakes. And then we picked a hard question. By the way, what I've just showed you for this solution, if you look online, you will not find this solution. The solutions online are much more messy. And what this is here is this is a technique called mass points. And that's actually my opinion of the best way to learn. The best way to learn is if somebody can give you problems where the problems are specially hand-picked so that you can do it in the normal way and you can also do it in the fancy way, which is it's a more advanced way to solve these questions. And that way you can learn advanced techniques while also looking at questions that you're used to seeing. Somebody asked, do I drink Coke or do I drink coffee? Actually, this is just water. All right. Oh, I see. Is the Daily Challenge a person or is it a robot? Are you talking about the logo down here? That's just my name. That's Luo. But the Daily Challenge with Po Shen Lo, that's a math course where, as you guys probably know, I teach the lessons in that course. Okay, more questions. Oh, somebody wants to know what crazy things to stop COVID-19 did I do? This is actually the Novid app. In fact, I understand that in Australia, you guys have some kind of a COVID-safe app. In fact, by using math, so I use math to do the things that I do. I love math. And you can use math to make the COVID-19 contact tracing app detect distances more accurately. I mean, you may or may not have heard that the Bluetooth-based detection of how close people are is actually not accurate. And so we use ultrasound. I actually use some techniques from PhD level mathematics to go and think about how to go and detect more accurately. So that's what we do. Okay, but there's an entire, if you're curious about the math behind COVID-19, actually there's a lot of math, and that's in fact going to be our next, our next course that we're going to put out. More questions. What else do we have? People asking what's my net worth. I don't know. Actually, at this point, I really don't know. I spend almost all of my energy trying to do these kinds of things, some of which produce value, some of which don't. And in fact, why the app to stop COVID that we made, why it exists at all, is because the earnings that we had from the course that we sell, we actually just donated a lot of those earnings to go and create that app to try to help people in the world to be healthy. So I don't know what my net worth is, but I'll tell you my net happiness is quite high because I believe that what I'm doing is interesting. Shirley Wu, do I have any courses like the one today? Well, what we try to do with all of our courses on the Daily Challenge, this is our Daily Challenge course series. I just actually try to ask questions that are at the fringe of your knowledge, and the explanations are all, the same style. We use the same studio where I shot this. But when it comes to, do I have any of these other like live streamed direct classes, I don't do this often. In fact, I did this as an exception for all of you guys. I generally don't do this at all. And yes, do I charge money for this particular class? Actually, we just did this for if you happen to be in a group where there were a lot of people in the group which joined our online course series. That one charges money. But I never directly charge money for this kind of a stream. And that's because to me, my time is generally spent trying to help as many people as possible. And so to me, these kinds of streams are relatively small. As you know, I'm working on trying to stop the spread of COVID. That thing could help like 1 billion people, so I'm going to work on that. So this particular thing that we're doing, what this particular activity is about, is that this kind of a live stream I generally will not put for any price. On the other hand, what I do is that this particular stream, let me be more clear. this stream actually has a price which is not zero either. The price of this stream is priceless. I have many, many other people who ask me to do a stream, and the answer is no, I refuse to do it for any price. But what we did here is, if the impact was big enough, meaning if there were, a lot of people from the Sydney area which joined our online school, then I'll do this one. So that's just why I don't actually do this kind of a stream again for a price. Okay. So yeah, I understand people like the live classes. Again, I'm sorry, my time actually is mainly spent trying to stop COVID-19. More questions. Okay. Somebody asked, are there any books I can recommend? Peter Pan is wondering, are there any books that I can recommend? Well, honestly, I think that in today's generation, these kinds of videos might actually be more efficient than books. I grew up without videos. I grew up in a generation where we only had books, so books were okay. But I think that today, if you want to learn the most efficiently, what you just saw here is more efficient than trying to read one line, one line, one line. Of course, it's good to learn to read. It's good to learn from books. Learn how to read. Sorry, it's good to learn how to learn from books. But it's more efficient right now just to use videos. I see that Yan Li has asked, did you graduate from Harvard? No, I graduated from a school called Caltech, California Institute of Technology in California. And then after that, I went on to Cambridge in England for a master's, and then I went to Princeton for my PhD. But I actually don't think that the school itself is the most important. I work with many, many top students in the world. What is most important is what you do afterwards. And if you learn how to use your techniques, your skills in some more creative ways, then you don't actually just have to, I guess, do a normal job. In fact, right now, I'm coaching the national US team for the Math Olympiad. And every single night, I run sessions for them, which are not teaching math, but teaching them how they can have a bigger impact with the lives that they have. My goal with all these people is that they will go on, and 20 years later from now, when there is COVID-39, I'll be too old to do anything about it, but they'll come out to help. Oh, do you believe that mathematics has a place in chemistry or other scientific fields? I think that a lot of things can be solved with a mathematical way of thinking combined with facts that are from the fields themselves. I myself love all of these fields, and so when I was learning things, I didn't only learn math. I learned math, I learned physics, I learned chemistry, I learned biology, I did a lot of engineering type things, I like to build things, I learned computer science. You need to learn all of those things. Somebody asked, what are your strongest subjects? Actually, my strongest subjects, I think the main one I have is the mathematical thinking. That's my strongest subject. But I went and learned everything else, and I'm always learning everything else. So I encourage you to do the same thing. But if you use math, you can use math to really understand each of the other things. And then it's easier to learn all of those other things too. Do I like the Hunger Games? Asks Caroline Liu. I actually don't watch any TV or movies, so I'm a little bit ignorant on that. I don't quite know what that means. Again, the reason is because I just generally work on these other bigger projects. All right. I see that some people are asking, can you leave now? Of course you can leave now. I mean, we have actually finished the hour. I'm just giving you some bonus time, right? So the bonus time is called, since we were a little bit late, I'll stick around, answer some of these random questions. If you need to leave now, go and leave now. That's fine. I understand. Oh, I see. Septify says I should make a masterclass with the masterclass thing. Well, honestly, that's what the daily challenge is. So if you look at the daily challenge with Po Shen Lo, our online math school, that is our own masterclass. And in fact, we create everything with our own professional studio. So in fact, we don't need to do it with the masterclass. We just do it straight here. I see Heidi Ni and many people are asking, do I like AOPS? I think that AOPS, Art of Problem Solving, has a fantastic free forum. I think that their free forum is a great thing. And if you go to their free forum to go and discuss mathematics, you'll find other people, and you'll find lots and lots of these answers to various questions. I think that's fantastic. Okay. Somebody asked, is Daily Challenge easier than AOPS? Now, AOPS does have some paid classes, and their paid classes are, they have some paid classes which will go into the more advanced things like high school proof type mathematics. What we are doing with the Daily Challenge is we're trying to cover all of the middle school, the early secondary school stuff, and also get you a good way into the high school. So we intend to actually help a huge number of people not only get in, but also get to a pretty good level. When you finally get to this like super top level, I'm not sure that I will actually be making classes for when I say super top level, I mean like the top 100 people in the country, in the United States. I'm not actually going to spend my time making those kinds of classes. Those kinds of classes are not asking you any question like this at all. Those kinds of classes are asking you things like, prove that if you had a prime number, and if you took the prime number to a power which was 1 less than the prime number, then when you divided it by something else, divided by, let's say divided by another number, then you conclude about the primeness or compositeness of the result. I'm just giving an example. It's like you write lessons, you write like a proof about this. So that's something which only a very few people in the US engage in, and I will probably not be making classes for that. Instead, I try to help everybody be really good at the core bread and butter stuff. Bread and butter, I'm not referring to the school stuff. I'm talking about the bread and butter for all competitions, which is what most people are doing. Okay, let's see. Oh, somebody asked what grade is AMC 8 meant for? AMC 8 in the United States is meant for anybody which is 8th grade in the US or younger. Okay. So, somebody said, would you rather Australia or America? I actually really enjoyed Australia. I went to Australia in March. That was the first time in my life I'd ever been there. And I remember thinking, I definitely want to come back as soon as the COVID is over. So I'll be back. Okay. I see that people are asking, they're curious about the news and saying, do you see Black Lives Matter protests on my street? No. So I actually don't see those protests on my street. Those are actually not all over the US. Do I teach calculus? No, I teach only more advanced mathematics in the university, Carnegie Mellon University. I see Chanel T has asked, what are your biggest projects you've ever worked on? I can tell you. There are 3 of them. Well, okay, there's a few more. So the biggest one I worked on before was coaching the US Math Olympiad team, and I still do that. But when I say before, what I mean is that used to be my biggest project. Now I do bigger projects. Then I started a website, xp.com, expii.com. If you're curious, you can go and take a look. That's free. That's to help the world. expii.com. That teaches math and science for free to everyone in the world. We have about 300,000 people who come through that every month. So that's like a certain scale. The other project that I was working on was the Daily Challenge, which is how we got to know all of you. Daily Challenge with Po Shen Lo, those are math classes that we think teach math in a more creative way and really help you to learn how to invent your own ideas. And the biggest project that I'm working on right now is this Novid app. That's Novid. And this is the biggest project because this is actually world scale. And so this thing now has about almost 50,000 people all over the world who have gone into it, who have installed Novid. And what we are trying to do is we are trying to actually stop the spread of COVID in the entire United States of America. So that happens to be the biggest project that I've ever worked on. All right. Unfortunately, I think we have basically hit time. So I want to thank all of you for joining our school. If you're here, you're in our school, you're in our online school, and you'll probably be learning math classes from me from the Daily Challenge online course series. Teaching more formulas, yes, I'll be teaching more formulas. Those are all in the course series. So even though you won't see me here in this kind of like a live interactive way, you'll be seeing me teaching you all kinds of different math. So welcome to our community. It's been a real pleasure getting to chat with all of you here on this chat. And I hope that you have a lot of luck as you continue to explore math and find out that it's pretty beautiful, pretty interesting. Happy learning. Take care. Bye-bye.